Hello and welcome to our lesson on understanding the area and perimeter of a triangle. Today, we will expand our knowledge of 2D shapes and learn how these concepts help us work out more complex areas. In this lesson, we have two primary objectives. Firstly, we will be able to understand how to calculate the area of a triangle. Secondly, we will also be able to work out a triangle's perimeter. We will then use our knowledge of triangles to work out more complex areas involving these shapes. After understanding these foundational concepts, we will run through some practical examples to apply this new knowledge and solidify our understanding. Let's dive in and explore the fascinating world of triangles. First, let's start by thinking about how to work out the area of a triangle. To begin, we will turn to working out the area of a shape we might already be familiar with, a square or a rectangle. To work out the area of this shape, just multiply the length by the width. We can write this as the simple formula, area equals length times width. Triangles can come in different shapes and sizes with various angles, and this makes it a bit more complex to calculate their area. Let's start by considering a right-angled triangle. If we position this triangle next to our rectangle, it looks like the rectangle has been cut in half. So if you imagine the triangle as half of a rectangle, you can see that calculating the area of the right-angled triangle involves halving the area of the rectangle. Thus, the area of the triangle is area equals half length times width. For our formula, we substitute these words for height, meaning length, and base, meaning width. Therefore, the formula for calculating the area of this triangle is half base times height. But what about more general types of triangles like scalene or isosceles? We can apply a similar principle here with this scalene triangle, side lengths A, B, and C. Let's think about drawing a perpendicular line from the top vertex or corner of the triangle down to its base. This line represents the height of the triangle, so let's call it H. As you can see, the line H divides triangle ABC into two right-angled triangles. Let's call the base of the first one X and the second one Y. We can use the same area formula we worked out for the right-angled triangle and adapt it for a more general triangle. The formula for the area of a right-angled triangle was half base times the height. So now let's think about how we can find the area of the two right-angled triangles we have here. For triangle 1, the base is X. For triangle 2, the base is Y. The height for both of them is H. Therefore, the total area of the entire triangle can be written as half X times H plus half Y times H. We can simplify this to area equals half X plus Y times H. Remember that X plus Y equals the base of the entire triangle. So we can replace X plus Y with B. This should look familiar. B is just the base, and therefore we have reached the same formula as before. The area of this triangle is also half of the base times height. This consistent formula applies to all triangles regardless of their shape. Now let's move on to the perimeter of a triangle. Calculating the perimeter of a triangle is straightforward. Unlike the area, where you need to consider the specific shape and angles, the perimeter is simply the sum of all the sides. Perimeter equals side 1 plus side 2 plus side 3. Let's now consider a triangle with sides of lengths 5, 6, and 7 centimeters. The perimeter is just these three sides added together. In total, this means that it is 18 centimeters. That's all there is to it. Let's now apply this knowledge to problems. We'll begin with a simple case to understand the basic concept of calculating the area of a triangle. In this diagram, we see a triangle with a base of 6 centimeters and a height of 4 centimeters. To find the area, we turn to the formula, area equals half base times height. We know these values, so all we have to do is substitute them in. Area equals half 6 centimeters times 4 centimeters. This means half of 24 centimeters squared. This gives us 12 centimeters squared. Note that when you calculate area, You are multiplying two lengths, so we need to make sure the units of length are same in both the base and the height, and that in your answer, the units should be squared. Now let's use our understanding of triangles to calculate the area of a more complex shape. We are going to try and work out the area of a parallelogram. A parallelogram is essentially just two triangles with the same area. If we have the right information, we can work out the area of one triangle and double it to find out the area of the entire shape. Since these triangles are equal, let's just focus on one. The height is 5 centimeters and the base is 8 centimeters. Using our formula, we know that the area of triangle ACD is a half times 8 times 5. Simplifying this, we get that the area is half times 40, which gives us the area of ACD as being 20 centimeters squared. Remember, the area of the parallelogram is two lots of this triangle and is therefore 40 centimeters squared. In today's lesson, we expanded our understanding of 2D shapes by focusing on triangles, specifically how to calculate their area and perimeter. We began by comparing the area calculation of triangles to that of squares and rectangles, recognizing that a triangle's area is essentially half the area of a rectangle formed by its base and height. This led us to the general formula for the area of a triangle. Area equals 1/2 times the base times the height, or base times height divided by 2. Next, we moved on to calculating the perimeter of a triangle, which is simply the sum of its three sides. This process is straightforward and does not depend on the triangle's angles or specific type. By mastering these calculations, we are now equipped to tackle more complex geometric problems that involve breaking down intricate shapes into triangles. Understanding how to find the area and perimeter of triangles strengthens our foundation in geometry